Right, Hellier College math students, let's learn how to solve linear equations. Now, this is a topic that can be daunting at first for some students, but with some sound principles and a bit of practice, you'll find that it's quite manageable. Now, the main thing to remember is that this is like a game of opposites. So we need to remember the four mathematical operations, just addition, subtraction, multiplication and division, or plus, minus, times, divide. And we need to understand what the opposite of each of these is. So you might have an idea about this. I'll give you a moment to think about what the opposite to each of these operations is. So when I talk about an operation, a mathematical operation, I'm talking plus, minus, times and divide, and the opposite to plus is minus. And what's the opposite to minus? Plus. What about the opposite to multiplying something? Well, that's to divide something. So of course the opposite of dividing is timesing. So how do we use this to solve linear equations? Let's have a look. Okay, so this first one up in the top left here, x plus 3 equals 8. Now what we need to do is make x the subject of this equation. So basically that means get x on its own. So we just have x equals some number. Now right now x is not on its own because it has a 3 next to it. We want x to be on one side of the equal sign all on its own, and that 3 is stopping this from happening. So we are able to take that 3 over to the other side of the equal sign, and it'll do the opposite to what it's doing on this side. So on this side, on the left, it's plussing. It'll do the opposite to plus on the other side, which is minus. So that plus 3 becomes a minus 3 on the other side. So x equals 8 take 3, which is 5. Now x is on its own, it's the subject of the equation. Okay, so now with that knowledge there, and having seen that example, you might like to try the next few on your own by pausing the video, then I'll have a go at them. Okay, so next one here, x plus 2 equals 7. Okay, so I'm going to do the same thing. I'm going to take that 2 over the other side, and it does the opposite, which is minus 2. So x equals 7 take 2, which is 5. Now, we don't need to show this arrow coming over each time. We could just show it like this on this next one. Let's see. We've got x equals, now the 6 is going to go over the other side, that's a negative 6, becomes the opposite of negative. This time it becomes plus 6, which gives x equals 5 plus 6, which is 11. So x equals 11. So you don't have to show this arrow pointing over here. You can just show the rearranging like this. That's fine. Okay, what about this one? Okay, so x equals, okay, we've got our negative 2, and this 8 is going to come over the other side and become plus 8. Does the opposite of negative 8, which is plus 8. So think back to directed numbers. What's negative 2 plus 8? X equals 6. Alright, so there's those ones where we're doing opposites to pluses and minuses. Now we've got a slightly different looking one. We've got 4x equals 16, so there's nothing plussing or minusing here. What do? Well, obviously that 4 is stopping the x from being on its own. So that 4 needs to go on the other side and do the opposite. On this side, what's it doing? It's timesing by x. So we take it over to the other side and it divides. So instead of times 4, it does divide 4. So x equals 16 divided by 4. 16 divided by 4 is 4. Okay. Similar situation here. Now this one can be really confusing because students see, oh, that's a -3, so that must do plus on the other side, the opposite. That's tricky. It's not minusing from the x or subtracting from the x. That -3 is actually multiplying by x. So in this case, the sign won't change. So this is just something through experience that you'll remember. So that -3 is going to go over the other side and it's going to divide. And it doesn't become a positive when it goes over. So x equals -12 over -3. Well, 12 over 3 is 4. Negative over negative makes positive. So positive 4. So that can be tricky to remember that, oh, that's a -3, but it doesn't plus on the other side. Okay, so we'll need to practice this one. Right, so negative x equals 10. Well, what is that number in front of x? There's nothing there, right? But what does it mean when nothing's there? Well, that means the number 1. That's just like -1x. And what is this -1 in front of the x doing to the x? It's timesing, just like back here with the -3. So this -1 will need to go over and divide on the other side. So x equals 10 over -1, which is -10. So that'll work any time. Like, just for example, let's say you had a really similar one like -x equals 8. Well, that means positive x equals -8. Yeah, so that always works. If there's a negative in front of the x, you can just take it over and put it on the number on the other side. Works every time. All right, x divided by 4 equals 10. Okay, what do we do with this pesky 4? Well, he's dividing on this side, so on the other side he'll times. So x equals 10 by 4, 40. And very similar here. You might want to pause and have a go at it. Okay, now I'll do it. Okay, x equals, okay, the 5 is dividing on this side, so it times is on the other side. 4 by 5 is 20, negative by positive, -20. Okay, so that's how we solve those linear equations. You've got to remember it's a game of opposites. So check the video description for the questions to try from the book.